Question number 1. If x is a random variable that follows the Poisson distribution with parameter lambda, what is the recurrence relation that generates probabilities? So x is a Poisson distribution, follows a Poisson distribution with parameter lambda. So the mass function is f of x is equal to e power minus lambda, lambda power x by x factorial. So let's call this 1. F of x can also be written as p of x. So suppose we take probability of x plus 1, e power minus lambda into lambda power x plus 1 by x plus 1 factorial. You know, x plus 1 factorial can be factorized as x plus 1 into x factorial. So this is the statement for probability of x plus 1. You call this 2. Suppose you divide p of x plus 1 divided by p of x. So this divided by this. So e power minus lambda will get cancelled. We will have lambda power x plus 1 by x plus 1 into x factorial. Because you are dividing with this, you should take the reciprocal into x factorial by lambda power x. So probability of x plus 1 by probability of x is equal to lambda by x plus 1. So if you adjust this, you will get probability of x plus 1 is equal to lambda by x plus 1 into probability of x. So this can be used as a recurrence relation for generating higher Poisson probabilities. I mean probabilities of higher values of x given the lower values of x. All that you need is the x value and the Poisson parameter lambda. You can see that A is a correct option for this problem. Question number 2. The conditions under which the binomial distribution tends to the Poisson distribution. In fact, this has been covered just now in the review. So conditions under which binomial distribution tends to Poisson distribution. The answer is n should be large, when you say large, much greater than 30. P should be small, that is extremely low probability of success. Then NP to be constant. In fact, we designate this NP as lambda or sometimes M. Both of them are valid symbols. So under these three conditions, we say the binomial distribution tends to Poisson distribution. So let us remember one thing. Poisson distribution deals with rare events. So this should be deeply registered in everybody's mind. Such things are not relevant in the case of the binomial distribution. Question number 3. If x is Poisson distributed random variable with the property that probability of x is equal to 1 is half times probability of x is equal to 2, what is the probability that x takes values less than 3? So let us first write the mass function. Probability of x is equal to e power minus lambda into lambda power x by x factorial, where x is greater than or equal to 0. Now if you take the information given to you, e power minus lambda, lambda power 1 by 1 factorial is half e power minus lambda, lambda square by 2 factorial. So if you now cancel off e power minus lambda and 1 lambda, so 1 is equal to lambda by 4, which implies lambda is equal to 4. This is a Poisson parameter. Now the question is probability of x less than 3. So probability of x less than 3 is nothing but summation e power minus lambda, lambda power x by x factorial, x is equal to 0 to 2, because the permitted values are the discrete values 0, 1, 2. These are the values less than 3. So if you take e power minus lambda common, you will have lambda power 0 by 0 factorial plus lambda power 1 by 1 factorial plus lambda square by 2 factorial. So this is e power minus 4 into 1 plus 4 plus 16 by 2 is 8. So this will be 13 e power minus 4, an extremely low probability. Please check C is the correct option for this problem. Question number 4. If x follows a Poisson distribution with standard deviation 2, what is the estimate of probability x greater than 2? So let's look into the data. X is Poisson distributed. Therefore, the mass function is e power minus lambda into lambda power x by x factorial, where x can take any value from 0 to infinity. Standard deviation is 2. Standard deviation is 2 implies root lambda is equal to 2, which implies lambda is 4. All of us know variance is lambda, so standard deviation is the square root of lambda. So probability of x greater than 2 means summation e power minus lambda, lambda power x by x factorial. X greater than 2 means the count starts from 3, so 3 to infinity. But this is a very long calculation, so we go for the reverse calculation. Probability of x greater than 2 is the same as 1 minus probability x less than or equal to 2. So this is nothing but 1 minus e power minus lambda, lambda power 0 by 0 factorial plus e power minus lambda, lambda power 1 by 1 factorial plus e power minus lambda, lambda square by 2 factorial. So 1 minus e power minus lambda into 1 plus lambda square by 2. So 1 minus e power minus 4 into 1 plus 4 plus 16 by 2 is 8. So 1 minus 13 e power minus 4. So the option for this problem is C.